The Google Sheets LOGEST function. LOGEST function, given the data about an exponential growth curve, LOGEST function calculates the various parameters about the best fit ideal exponential growth. In this video, we will use the multiple independent variable example. Copy this and show the LOGEST and LINEST function, derive the LOGEST and the LINEST function. We don't need the formula. We don't need this formula, but we do need the data set. So we cut and paste it. Center it and put borders and use the description as our guide. So paste. Here we have the description of it, the output of each dataset, the logest function. And here's the dataset. We have data y and data x. Let's enter the logest function. Logest data y and data x. And we'll show the full statistics. Here are the 10 outputs. So the values of the coefficients, these are the values of the coefficients, they match. The y-intercept, 7.92, is also match. The standard error values of the coefficients, also match. The standard error value of the y-intercept, we have a match here. The coefficient of determination, also known as r squared, and the standard error of y-estimate, also known as TX, 0.0323. The F statistics, 1030, this is also match. The number of degrees of freedom is a match here. And the regression sum of squares, also known as ESS, that's 2.15. The residual sum of squares, also known as RSS. And this unused cell, we mark it red because there's no statistics. We will calculate each output. You can use LINEST in this. So we use LINEST. So to do that, we have to linearize our dataset by converting we use array formula of the ln of the y values. Now that we have converted the y to the linear form, we can now use LINEST. Data y, this time this is our data y, and data x. Let's show the full statistics. You'll notice the standard error values of the slope and intercept, they're the same. R squared and stay x, they're the same. F statistics, they're the same. And the degrees of freedom, regression sum of squares and residual sum of squares, they're the same. But the coefficients, they don't match. That's because the logarithm of the logest coefficient, is the LINEST. Let's prove that. It's array formula, ln of these coefficients. Now, the output here, the linear coefficients match to our LINEST output. We'll calculate the rest of these values, the rest of these outputs, using the matrix solution. We can now hide this. And here's the matrix solution. We begin with the 1 comma x matrix. So this is 1, and our data y will, our x values will be array formula of these values. So we have the data x1 column and the data x2 column. We can now enter the Pijorina inverse. So it is our min inverse m mult transpose of the 1 comma x matrix and itself. And we enter the Pijorina cofactor, which is m mult transpose of the 1 comma x matrix. And this time we use the lny values. The lny values. Now that we have both Pijorina inverse and Pijorina cofactor, we calculate the coefficients. So it is m mult of the Pijorina inverse and the Pijorina cofactor. This are ln b0, ln b1, and ln b2 match to these outputs, match our LINEST output. Now we can calculate for the ln y hat, which is equal to m mult of the 1 comma x matrix and the coefficients. Now that we have the ln y hat and the ln y, we can now calculate the residual sum of squares, which is equal to sums of squares of the difference of ln y and ln y hat. And our residual sum of square matches to our LINEST and LOGEST output. Next, we calculate the degrees of freedom of the denominator, which is rows minus columns. Before we do that, we calculate the population, which is rows of the 1 comma x matrix. That's our population. Now we can calculate degree of freedom, which is rows minus columns. So rows minus columns of the 1 comma x matrix. 6. Our degrees of freedom match to our LINEST and LOGEST output. Next, we calculate for the STAY-X, standard error estimate, which is square root of residual sum of squares divided by degree of freedom. 0.0323 matches to our LINEST and LOGEST output. Next, we calculate for the standard error values starting with B0. This is equal to STAY-X times square root of Pijorina 1. 0.1549 matches to our LINEST and LOGEST output. Next, we calculate for the standard error value of B2, which ln B2, which is STAY-X times square root of Pijorina 2. 0.02522 matches to our LINEST and LOGEST output. The standard error value of LNB2. So square root STAY-X times square root of Pijorina 3. And this matches to our LINEST and LOGEST output. Next, we calculate for the regression sum of squares and total sum of squares. Before we do that, we have to calculate the total sum of square, which is equal to n times variance of the population ln y. And now we can calculate for the regression sum of square, which is total sum of square minus regression sum of square. 2.158 matches to our LINEST and LOGEST output. And we calculate for the r square, which is equal to regression sum of squares divided by total sum of squares. And this matches to our LINEST and LOGEST output. Now we can calculate the F statistics. But before we do that, we calculate the degree of freedom of the numerator, which is equal to columns of the data x, meaning independent variables. And that's 2, because there are two independent values, x1 and x2. So we can calculate for the regression sum of squares, or the F statistics. F statistics is regression sum of squares divided by degree of freedom of the numerator divided by stay x squared to the power 2. 1030.65 matches to our LINEST and LOGEST output. This completes the comparison of the LOGEST and LINEST function in multiple exponential regression. No other Google video or YouTube video has